For over 100 years, one single invention has pretty much defined how we build everything, from our cars to our airplanes. But that whole era, it's coming to an end. There's a quiet revolution happening on factory floors right now, and believe me, it's about to change everything. Let's take a look at what that future's all about.
That's a pretty bold statement, right? It's from the Robot Report, and it just perfectly sets the stage. We're not talking about some minor tweak or a simple upgrade. Oh no. We're talking about a complete, fundamental shift away from a system that's been the backbone of manufacturing since like 1913. So you might be asking, why fix what isn't broken? The assembly line was absolutely genius for mass production, for making the same thing over and over. But in today's world, where we want everything customized and supply chains are super complex, that rigid step-by-step process is actually becoming a major bottleneck.
And this, right here, shows you the difference in a nutshell. An assembly line is linear. If one little station goes down, the whole thing grinds to a halt. It's a classic single point of failure. A swarm, on the other hand, well, it's decentralized. It's resilient. Think of it like this. It's the difference between a single train track and a whole city grid of streets. If one road gets blocked, no big deal. Traffic just finds another way to get there. The system just adapts.
So what exactly is this swarm we're talking about? Well, the funny thing is, the concept isn't actually new. It's an idea we borrowed directly from the natural world, and it is incredibly powerful.
The core idea here has a fancy name, biomimicry. But it's simple, really. Just picture a bee colony. There wasn't one manager bee telling every single other bee what to do. Nope. Instead, they all communicate and coordinate based on a few simple local rules. And together, they achieve these amazingly complex goals. Swarm robotics just takes that exact same idea and applies it to machines.
And the potential uses for this stuff are just massive. We're already seeing it pop up in advanced manufacturing and in those giant warehouse logistics centers. But you can use the same principles for teams of drones in farming, or for robots in search and rescue missions, and even for exploring other planets. The sky is literally not the limit here.
Okay, before this whole beautiful self-organizing system to actually work, the individual robots have to be able to talk to each other. And how they communicate, well, that's absolutely critical. Choosing the right way for them to talk involves some pretty serious trade-offs. And this table really lays out those trade-offs. Let's look at Wi-Fi up in that top row. The data rate is really high, which is great for sending a ton of information. But then look over at the power consumption column. It's also high. It'll just suck the battery dry on a small robot in no time. Now, check out Zigbee down at the bottom. The data rate is way lower, sure, but so is the power consumption. That makes it perfect for huge swarms of smaller battery-powered robots. So, here we are with these incredible swarms, all communicating efficiently, building our future. It sounds perfect. But that communication, the very thing that makes them so powerful, is also their biggest weakness. There's a hidden vulnerability in their secret language that could bring the entire system crashing down. And this is really the central question, isn't it? If the communication that makes all this incredible coordination possible isn't secure, then what? What happens if an attacker can hijack the whole swarm and turn that beautiful collaborative dance into total chaos? The threat comes from a technology that honestly sounds like it's straight out of science fiction: quantum computing. See, all the digital locks we use for everything today, our online banking, our secure messages, all of it, that stuff is based on math problems that are just way too hard for our current computers to solve. But for a future quantum computer, those locks might as well be made of glass. The quantum computer's secret weapon has a name: Shor's algorithm. And you can basically think of it as a universal master key. It is specifically designed to solve the exact kind of math problem that all our current encryption relies on, which would make that encryption totally useless. And please, don't think this is some far-off problem for our grandkids to solve. The race is already on. Right now, bad actors are using what's called a harvest now, decrypt later strategy. They are stealing encrypted data today, knowing they'll be able to crack it open in the future. Meanwhile, new security standards are expected by 2025, and experts think a quantum computer powerful enough to matter could be here within just 10 to 20 years. The clock is ticking. So, is it all doom and gloom? Are we just doomed? Not at all. Even as this new threat is coming into focus, the world's best cryptographers are already building the defense.
they are forging a brand new kind of digital shield. It's called post-quantum cryptography, or PQC for short. And what it is, essentially, is a whole new generation of encryption. These new algorithms are built on different, much harder math problems that are specifically designed to be tough for both the computers we have now and for the quantum computers of the future.
But building this quantum shield isn't as simple as just flipping a switch. There are real-world choices to make. This chart shows that perfectly by comparing the speed, or what engineers call latency, of two different PQC algorithms. The one on the left is pretty fast, only about 48 milliseconds to make a secure connection. But look at the one on the right, it's way slower. And this really highlights the key point. Engineers have to constantly balance things like speed against security and how much computer power it takes. There's no single perfect answer for every robot swarm out there.
Okay, so we've been talking about robot swarms and quantum threats, and I know it can all feel a bit abstract. So let's bring this all back down to earth and see how these ideas are already playing out in the real world today. Welcome to the BMW factory in Regensburg, Germany. That number you see, 10,000, that's how many trips their fleet of transport robots makes every single day, just delivering parts around the factory. The scale of this operation is it's mind-boggling. And this example brings everything together. You have a fleet of nearly 200 robots, all being coordinated by a cloud system. They have to deliver parts not just on time, but just in sequence, meaning in the exact order needed for each custom car being built on the line. Can you imagine what a communication failure, or worse, a hacker getting into that network could do? It would shut down production instantly. For a system this complex and precise, future-proof security isn't just a nice-to-have, it's an absolute necessity. So, as these intelligent swarms of robots start to build our world, everything from our cars to the satellites we put in orbit, the ultimate question is still out there. The technology is here, it's real, but are we ready to protect it? The entire future of manufacturing might just depend on how we answer that question.